Welcome to my class in continuation with Unit 3, Statistical Tools and Interpretation. We are doing index numbers now. And in index numbers, we finished with simple index numbers, simple method of measuring, constructing index numbers, the simple aggregative method, and simple average of price relative method. And we also finished with the weighted. Today we are going to do Fisher's formula for solving the weighted aggregative method. Before that, what is an index number? As we've already done in the previous classes, it measures changes over, say, over a time period. So that is why it is so important for policymakers. And talking about methods of constructing weighted index numbers, weighted aggregative method, we've done with Laspier's method and Paschet's method. And today we are going to do Fisher's method, as I just pointed out. So what is Laspier's method? Laspier's method was taking, of course, we know that index numbers, it is aggregative index number, simple, is sigma p1 upon sigma p0 into 100. So into 100. And Paschet's is, we take Q0, that means base year weights. And in Paschet's method, we take the current year weights, Q1. Okay, and the index number, as we said, is sigma p1 upon sigma p0 into 100. That's index number. But along with weights, it becomes like this. So once again, what is an index number? And just to quickly tell you what is an index number, it is a statistical tool for measuring changes in the magnitude of a group of related variables. So it measures the change in the group of related variables over two different time periods. Okay. So that's why they are known as barometers of economic activity and all of that. So simple methods of constructing index numbers, simple and weighted. In simple, we did the what is simple, in which all the commodities are of equal importance, and what is weighted, where weights are given to various commodities because depending on their importance, some are more important than others. And weighted in this there are two methods: weighted aggregative method and the weighted average of price relative method, which we'll be doing in the next class. But in this class we are doing the weighted aggregative method, and in this method appropriate weights are given to different commodities to show their relative importance in the group. And there are many formulae to construct weighted index numbers, such as Laspier's method, we have Paschet's formula, we have Fisher's formula, and besides them there are many others, but we are going to do these three. Alright, so let me come to this and once again reiterate what it is. So let me see if we can see. Yeah, okay. So in the Laspier's method, this is the numerical which we have, in which the commodities are given, the base year price is given, the base year quantity is given of 2010. So 2010 forms your base year price of price and quantity, and the current year price is of 2050. So prices and quantity are given. So we took up the say Paschet's method. What did we take? We took the current year prices, and in the current year prices, what do? We take P0 into Q1 and P1 into Q1. Okay, so that is how we worked it out. But here it will be summation of, where do I write? Summation of P1 and Q1 into Q1 and that is POI is equal to summation of P1 into Q1 summation of P0 into Q1. So we take the current year weights and this is how we do, and what we get, the answer that we got. Now let's just do one or two just to show you. Let's take P0 and Q1. P0 and Q1. Alright. So 20 into 6 is 120 for A commodity. 50 into 5 is 250. And P1 into Q1. What is P1? P1 into Q1. So 40 into 6 is 240. 60 into 5 is 300 and so on. Now we will, that's how. And what did we do? When we summed it up, when we summed up P1 Q1, we got 1790, and when we summed up P0 Q1, we got 1470. And this is how we arrived at by Pasteur's method, 1790 divided by 1470 into 100, and what we got was 121.77, which means that there is a net increase of 21.7% in the price of commodities in 2015 as compared to 2010. Okay, now base year, we took the base year quantity here. Okay, that is Q0. So we talked about Q0. So base year quantity. So how did we come at the base year quantity? So it is P1 into Q0, 40 into 8. P1 into Q0. Okay. So that is how we worked out the price. P1, yeah. What is P1? P1 into Q0. So 320, let's just, and so on. So then we take P0 into Q0. So what is P0? 20 into Q0, 8, 160, and so on. And then we, you can see, why I'm not going to detail this, that we've done it in the previous classes. Got to go back and see it. And then we add them up. So what do we get? For P1 Q0, when we add it up, we get 2070, and when we add this up, sigma P0 Q0 stands at 1660, and when we multiply it by 100, we get is 124.7. This is the formula. So which means that there has been a net increase of 24.7% in price of commodities in 2015 as compared to 2010. So when we work it out. And in this, we are going to do the Fisher's method. Now, in Fisher's method, what we do is, it is a combination of the Laspier's method and Pasteur's method, under root into 100. This is how we do it. Alright, so P01, L into P under root into 100. And then we find out the square root, and this is how we will do it. So again, what is Laspier's method? Laspier's method is what? Sigma P1, I haven't written here. What should I write here? So Laspier's method, which are the weights that we use in Laspier's method? We use the, which weights do we use? Which quantity? Quantity of the base here. So sigma P0 into Q0, P1 into Q0. And Pasteur's method. So in Pasteur's method, what do we do? So sigma P1 into what? Into current year weight. So I'm going to write Q, that is current year quantity. And P0, sigma P0 into current year quantity. So whatever we get here, so then we work it out. So 2070 upon 1660, what we get is 1.247 into, we work out 1790 upon 1470, we get 1.217 under root into 100. Now what do? We multiply that, we get 1.5176 into 100. So then take out the square root, 1.232 into 100, and index number comes out to be 23.2. It means that there is a net increase of 23.2% in price of commodities in 2015, that is current year, as compared to 2010, the base year. All right. So this is how it goes. It is, let me just once again let you know that which is the ideal index number. Obviously they say that Fisher's index number is called an ideal index number. Why? Because it is based on variable weights, and it takes into consideration, secondly, it takes into consideration the price and quantities of both the base year, quantities of the base year, and the quantities of the current year. So it's taking into consideration the price and quantities of both the base year and current year. And it is based on geometric mean, which is regarded as the best mean for calculating index number. That's what we've seen. And one more thing, which I don't think it's in your syllabus, or I don't know, we don't do it much, but you should be aware of this, just to be in the know of things. Let me just also tell you that Fisher's index number satisfies both the time reversal test and the second is a factor reversal test. Now, what is a time reversal test? The time reversal test implies that the formula for calculating an index number should be such that will give the same ratio between 2 points, no matter which of the two is taken as base. Time reversal means that if we change base year to current year and vice versa, then the product of the two indices should be equal to unity. Alright. Thus, an index number should work both ways, forward as well as backward. Then if you take the factor reversal test, on the other hand, that implies that just as a formula should permit the interchange of two items without giving inconsistent results, so it ought to permit interchange of prices and quantities without giving inconsistent results. That is, the two results multiplied together should be equal to value ratio. So, taking that into consideration, Fisher's method is a superior method. It's an ideal index number. So, I would want you to go and also check with that from your books. But right now, I want you to copy this in your notebooks. I want you to do this and make sure that you will open your course book, take an illustration from there, do the Fisherian method for constructing weighted index number, and then do one from the exercise. All right. So with that, in the next, we finish with the weighted and aggregative method. We do the next one. Okay.